So our solutions to the system, x prime equals ax or x prime equals ax plus f of t, will be a column matrix. So the definition is, for a solution vector on an interval I is a column matrix of this form. So x is equal to x1 of t, x2 of t, all the way down to xn of t. Just depends on how many unknowns we have. And these entries are all going to be differentiable functions, and they're going to satisfy the system x prime equals ax plus f of t, and f of t can be 0 if it's homogeneous. But this will be the solution. So in this next part of the process, what we're going to do is actually being given the solution, and then we're going to verify that it actually is a solution. So given the system, verify it, and in order to verify it, we're just going to plug stuff in. And if the left-hand side equals the right-hand side, then we know that it is a solution for it. There's a couple things that we have to do, though, in order to do that. And one is we're going to have to find x prime ourselves, because we're going to be given x, the solution vector, and we have to prove that it actually is a solution. So in order to find x prime, we just take the derivative of each entry. Alright, so find x prime by taking derivative of each entry of x, and then we're just going to plug it in. So left hand side has to equal the right hand side. Okay, so we want to verify x equals 1, 2, e to the 2t is a solution for the system x prime equals 4, -1, 2, 1, x. So first thing I want to do is rewrite x. This notation is used a lot, but really I need to distribute that through. So my x is equal to e to the 2t, 2e to the 2t. And in order to plug it into this equation, I need to know what x prime is. So x prime, we're just taking entry by entry. So derivative of e to the 2t is 2e to the 2t. Derivative of 2e to the 2t is 4e to the 2t. So that's my left-hand side. And now I'm going to work on the right-hand side. So I have my coefficient matrix times x. So this is my x. So I need to do matrix multiplication over here. Remember, when you multiply matrices, you go across and down. So I end up with 4e to the 2t minus 2e to the 2t. And then for the second row, I have 2e to the 2t plus 2e to the 2t. So that gives me 2e to the 2t and 4e to the 2t, which matches the right hand side, so therefore I verified that it is a solution. Alright, here I want to verify x equals 5 cosine 2t e to the negative t and 2 cosine 2t e to the negative t plus sine of 2t e to the negative t is a solution. Now, the original problem actually had the e to the negative 2t out, very similar to this one, but I didn't want to forget to multiply it back through, so when I recopied it, I just automatically multiplied each term by that, e to the negative 2t, because I didn't want to forget to do it later. Alright, and then we have dx dt equals 3x minus 10y, and dy dt is equal to 2x minus 5y. So we need to write that as a matrix. And I end up with x prime is equal to those coefficients, 3, negative 10, and 2, negative 5 times x. So I want to go and start plugging stuff in, but this is going to be kind of messy when I find x prime, so I'm going to do that first. So x prime, I have to use the product rule. So I have 5 cosine 2t times negative e to the negative t plus 5e to the negative t times negative 2 sine 2t. Alright, and then down to the next one. I mean, we can clean that up, but we can come back and do that. I have to use the product rule here, and then I have another term that I have to use the product rule there. So first I'm going to get 2 cosine 2t times e to the negative e to the negative t plus 2e to the negative t times negative 2 sine 2t. And then for the second term, I have sine 2t times negative e to the negative t plus e to the negative t times 2 cosine 2t. That is a lot just for that derivative, right? So what can we pull together? I have this 2 cosine 2t negative 2 cosine 2t e to the negative t, and then I have positive cosine 2t 2 times e to the negative t, so those two are going to cancel each other out. And then these two can be combined to like terms because they're both sine 2t e to the negative t, and that gives me a negative 4, and that gives me a negative 1 coefficient. So x prime, the bottom just combines to negative 5 sine 2t times e to the negative t, and then the top, when I clean it up a little bit, I get negative 5 cosine 2t e to the negative t, and then minus 10 sine 2t times e to the negative t. So that is my x prime. So that's just the left-hand side. And now I'm going to go and work on the right-hand side. So that is 3, negative 10, 2, negative 5 times x, which was 5 cosine 2t e to the negative t and 2 cosine 2t e to the negative t plus sine 2t times e to the negative t. So again, across and down. So multiplying that, I get 15 cosine 2t e to the negative t minus, I'm going to distribute that 10, so minus 20 cosine 2t e to the negative t minus 10 sine 2t times e to the negative t. And then for the next row, 2 times that gives me 10 cosine 2t e to the negative t minus 10 cosine 2t e to the negative t minus 5 sine 2t e to the negative t. So this first one, I can combine these two together, and that gives me a negative 5. And then for the second one, I get this and this are opposites. They cancel out, so I'm just left with negative 5 sine 2t e to the negative t, which the other page we can see that they match, so that is a solution.